We're going to proceed. Okie dokes. Anybody? Blake, Mackenzie? Oh, Mia.
Can you do 15 on 6.2?
6.2, number 15. Yes. All right. All right. So we'll start by getting ourselves a picture. This one would have been no problem to do in your calculator, or really by hand even, I think would have been fairly straightforward here, right? So y equals 0, x equals 1, and then x equals 2 is our axis of rotation. Let's get rid of these grid lines because nobody needs those. It's too busy. We'll zoom in just once. We'll drop that. And it's enormous. Okay. So the region that we're interested in is this guy right in here, right? And we're rotating about that axis, x equals 2. So we're going to get like when we think about this in 3 dimensions, the inside is going to be the same and the outside is going to like do that kind of thing. That's okay. You guys see that? Where this is like a circle down here, I guess, right? Okay, so you guys, what do we want to integrate by, the x or the y? Since it's a vertical, we're going to go with y. Yep, that's what I would do. So fairly easy to see that be integrating from 0 to 1, right? And the shape we have for our figure is going to be a washer, where that's like our inner and that's like our outer. Everybody's okay with that? So that inner radius, that's nice because that's just fixed. That distance is 1 everywhere. Sweet. The outer radius is going to be what? Well, from here to here is 2 units. And from there to there is x units. That's going to be 2 minus x. But we're integrating with respect to y. We need to rewrite x in terms of y, correct? So I know that y equals x cubed. So the cube root of y is equal to x. So pi times r outer squared minus r inner squared. Integrating from 0 to 1. So that's our setup. Mia, you feel okay there? Do we need to continue? We can if we need to, but I think it's, Yep, that's exactly what I would do. FOIL, combine some like terms, and then just there's no sneaky integration going on. Just your standard like power rule antiderivatives. Yeah, no problem. What was so hard about it? I'm just teasing. They're hard.
I think except for the 2 minus 1.
Oh, yeah. Yeah, you have to, again, like drawing in all the stuff that you know really helps. Had it been like rotating about x equals 0, then it would be like 1 plus cube root, because you have the 1 from here and then the x. So it just kind of depends on whether the outside, So just the picture really helps, as far as I'm concerned. Helps me anyways. Mackenzie? Yeah, sure. Hi, Paul. It's a Monday, but it's like the week before vacation.
Yeah.
Right? And Enzo. 2 people gone. But that's pretty good percentage on a senior skip day. So again, Mackenzie, I'm going to start by generating a picture.
I tried downloading Graphica.
Yeah.
Didn't work.
You needed the school to okay it? Yeah.
Very unfortunate. Literally 1984.
1984? Oh, because Big Brother's watching you, I see. I can see if like Miss McCaskey or somebody can come in one day and just walk.
I'm just gonna I'll figure it out. And I mean, I can use Desmos.
That's true. Yeah. Which is a perfectly reasonable. I'm not as familiar with that as I am this.
Yeah.
So this is what I use. All right. So 11, there's our region, integrating about the line y equals 1. When we do that, what is this thing going to look like? Yeah, it's going to look kind of like something like that. Something-ish, right? Okay, should we be integrating with respect to x or y? X, good. And we should be integrating from what x to what x? Yeah, 0 to 1. I mean, it should be easy to see that those intersect at 1, 1. Plus, it's y equals x squared, x equals y squared, which 0, 0, 1, 1 are obviously solutions to those. All right. So our inner radius is that, and our outer radius is that, right? Okay. So the inner radius, well, I know here to here is 1. Let me use a different color. And I know there to there is y. So Ri should be 1 minus y. Is that okay? And for there, I know that y is equal to x squared. Oops, nope. I know that x is equal to y squared. And I dropped the plus or minus on that because, well, it's also because it's clearly like the positive x value, right? Let's do RO, the outer. Again, that distance is 1. That distance is y. It's 1 minus y. And there I know that y is equal to x squared. So I have that. So we have pi times 1 minus the square root of x squared minus 1 minus x squared squared. Does that feel okay, Mackenzie? Yeah. And then from here, I would just FOIL everything. So like that distance is 1, the distance from the axis of rotation back to where it's the origin or the x-axis. So, and we know that like this distance is y, so like it's 1 minus y. And like that distance is the other y, so you get, again, 1 minus y, right, for the radius. And again, I can't put these things together without drawing the picture. Like I need to draw the picture to do this. You should need to draw the picture to do this. Like making sure you can draw the radius in at the right location. Like if you can't do that, the setup's gonna be impossible, right? Like that's kind of the key. And we're okay stopping here after the setup, Mackenzie? Okay. Again, if the integral was one that you wanted to do, just tell me and we can do it. But in the interest of time, I think the setup is really the hard part right now. I'm hoping the integration you guys feel pretty comfortable doing. So that's where I'd like to spend our time together, practicing the part that we're bad at. Or not comfortable with anyways. Maybe we shouldn't say bad. Right? You're like, I'm pretty bad at it. No, I meant the setup part. Yeah. Setup part is hard. It is hard. It is okay for it to feel hard. What's going to happen is all of a sudden you're going to be like, I think I got it. And it'll start feeling comfortable. But it takes some practice. It takes some time. It's okay. Let it take some time. Because it's not easy. Mia. 6.3, number 19. Yeah. Good idea to do a shell here.
On the test, will we have to be able to do, like, will you specify, do this problem with like the shell method?
No. But you know what we're practicing today? We're going to spend the entire day practicing how to tell which one you'd want to pick.
Can you use the shell method for everything?
Sure, but sometimes it's going to be really hard, like to get it set up. Well, as you get comfortable, it's relatively easy to see when you'd want to use a shell. And then, Mia, you said 19? Okay. Before I started typing things in, I just wanted to double check because, well, it's Monday and I'm bad at listening on all days, but, you know, And again, this would be hopefully a relatively easy one to kind of picture, right? There's nothing crazy going on here with y equals x cubed, y equals 0, and x equals 1. All right, and we're looking at this region here, right? And we're rotating about this fella. Now, if you ask me, no reason you couldn't use like washers to do this, right? Perfectly reasonable one to still do washers on. Wouldn't be wrong to do that. There's no reason you'd have to do shells, other than the directions in this one are saying use a shell. So if this looks like a washer problem, you're right. You could use a washer to do this. It'd be okay. And again, what are we going to get here? Yeah, it's going to be like, that's right. So it's going to be like a bowl, but it goes down to like something like that, right? You kind of see that? Okay. So, shell method. What should we be integrating with respect to? Y. It's the opposite rule as for the washers. Okay. So that's like my radius. And then back to my axis, or back through the function is like the height, right? Okay, what's the radius going to be there? 1 minus y, excellent. Put that out front. I'm going to run out of space. Does that feel okay? And what's the height going to be then? 1 minus x. Very good. You guys see that? Right. That distance is 1. That distance is x. All right. Now, what's the problem with 1 minus x? Has an x in it. What does it need to have in it? Y's. So we know that x is just the cube root of y. Oh boy. Oh boy. Mr. Kulik. Oh, and what are we integrating from? Yeah. And I think that'll do you. What do you guys think? You ready to try doing some of these figure out what you need to use problems? Okay. So let me drop these in. We're looking at 37 through 43. Oh, yeah. We're doing them right now. Whatever we don't finish, we'll let you guys work on. But we're going to do these right now. So find somebody that you want to kind of work with. Doesn't matter how many, 1s, 2s, 3s, I don't care. It's not like this is, you know. We're going to start on 37. I'm going to pause periodically and, you know, we'll talk periodically as we're going through, and then we go through together if we don't see what to do. Here's what I would say, and we're just going to worry about the setups. I don't even care about the integral right now, right? You guys know how to do the integration. I'm less worried about that than I'm the setups. So once you feel like you got a setup, we'll stop and yeah, get a calculator or get the grapher out, whatever you're going to use, computer, calculator, whatever.
You know, we should make like a mega desk. You know what? I'm down for a mega desk.